I recently posted a video about Claude Haiku, which is the smallest model of the Claude family, but still a very awesome multimodal model, which is quite accurate and even better than GPT 3.5 Turbo in many tasks. Today's video is about Claude Sonnet, which is the second model in the Claude family. It's bigger than Haiku, but smaller than Opus. I will soon post a video about Opus as well. So these three models are part of the Claude family of models by Anthropic. Today's video, just like the Claude Haiku video, is part of the Gen AI and LLM projects playlist on my channel. So make sure you check out all the other projects on that playlist as well. Now the reason you want to watch this video is because I'll take Claude Sonnet through its paces and put it through various difficult tasks. And we will see exactly how it performs. Now this will save you a lot of time, because if you're building a project and you're looking for the right LLM for the project, then you want to be sure it can accurately perform all the tasks you're giving it. And a video like this saves time because you see the model's capabilities, its weaknesses, and you get a code file where it's already been tested out. So you don't have to test it out from scratch yourself. So please watch this video till the end because it's a small video but covers a lot of details. I'll now be taking you through the code file and I'll leave the link to this in the description of this video. Make sure you make a copy of it so that you can refer to it later on. We start off by importing LangChain core, which has all the core features from LangChain. Now if you're not sure about how LangChain works, I have a few videos about LangChain basics on this channel as well, so make sure to check them out. Then we import Anthropic and LangChain Anthropic. That's going to help LangChain work well with Anthropic. Then we import OS and set our Anthropic API key. Now to be able to chat with our Sonnet model, we're going to import human message, system message, and chat Anthropic. We also get display and markdown because we will render the output in markdown. Using chat Anthropic, we set our model to Claude 3 Sonnet, and this will be available to us inside the chat object. We set the content of the human message to knock knock just as a small test, and we invoke a response from our model by using the chat object. And then we display the response in the output. And as you can see, the response is who's there. So now that we know that the LLM is responding and our test is successful, we can make it do more awesome things. We can stream the same message instead of a response in one go. And you do that by chunking and using the stream function. You get the same response, but it's a streamed response and is usually helpful when there's a long response from the LLM. And you don't want the user to keep waiting, so you can start streaming some chunks to the user so that while he reads the messages, more can be streamed. And this is exactly how ChatGPT works. You see the output being streamed in real time rather than a response in just one go. Now we'll create a chain. So first we import chat prompt template from LangChain. We've already seen prompt templates in the LangChain basics prompt template and few short learning video. Then we create our prompt using the prompt template. And then the prompt is, tell me a joke about the topic. And we pass the topic dynamically. Then we create our chain, which has a prompt and the chat. The chat, if you remember, has details about our LLM. We then invoke a response from this chain and we pass the topic as space. So this means we should see a joke about space, right? And we display the response, and sure enough, in the output, we see a space joke. It says, why did the astronaut bring a dog into space? And the answer is he wanted to take the first bark on the moon. This shows Sonnet is quite intelligent. Now, to be able to test the model more easily, we are going to define two functions. The first one is wrap text function, which is going to help us neatly format the response from our LLM into a proper paragraph by putting spaces between lines and making the text appear well formatted in the markdown output. So if you scroll down and look at the response of the instruction answering code, you will see it's a very well formatted markdown. And this is all being done because our second function, which is a generate function defined here, is calling the wrap text function. So the wrap text function has a few moving parts. It's splitting the input text into lines based on new line characters, wrapping each line individually and joining the wrapped lines together using new line characters. And it finally returns this wrapped text. The generate function is going to make it easier for us to call the LLM again and again because we want to do a few tests on it. So this function takes in the input text that we want the LLM to process, and we are setting the system prompt. Now the system prompt helps guide the responses of the LLM by asking it to behave in a certain way. So if you're making a project in a particular industry, you might want to tweak this accordingly. Then we're setting the static max length of 512 because that's good enough token length output. We set out messages array with system message and human message, where the human message is what we want the LLM to process, and it's the same as the input text coming to this function. And our system message is the same as the system prompt. Then our chat object has the details of the model, which is Claude 3 with temperature 0.7 and max tokens equal to the max length we just defined. In the next lines, we have the logic to actually call the LLM and invoke its response. and then extracting the text from the response in the text variable, and then calling the wrap text function on this received text, and finally printing the wrapped text in Markdown format. Now that our generate function is ready, all we have to do is call it with some input text. So in the next section, which is the instruction answering section, we give it a prompt, write a detailed analogy between mathematics and a lighthouse. Now please note that this is a very random task that requires lateral thinking and is something that most humans would struggle with. Now in the system prompt, we ask it to write its reasoning step by step as well, and we get a detailed output. And since you have access to this file, you can check out the output in detail, but basically I'm quite impressed because you get a really nice output. Next, we ask it to write the difference between llama, vicuna, and an alpaca, which are 3 different animals, but there are also 3 different large language models. So how will the LLM know if I'm talking about the animals or LLMs? That just comes down to the A before llama and an before alpaca. We wouldn't have these if we were talking about LLMs, and Sonnet is smart enough to understand that we are in fact talking about animals, even though I didn't really pass any context in the message. It's deducing the context from the sentence formation, and I can tell you most LLMs struggle with this. So in the output, you can see it's talking about the LLMs and giving us detailed differences between them, which is exactly what we needed. Now I'm going to ask it to write a short email to Sam Altman, but I'm going to ask it to do this 4 different times. And each time I'll have a different system prompt, meaning I'll ask it to act like a particular type of person. So in the first example, when I ask it to write an email to Sam Altman to open source GPT-4, I'm asking it to write its reasoning step by step. In the next example, I'm asking it to act like Freddy, who's a 5-year-old boy and is scared AI will end the world. In the next example, I ask it to act like Kate, the vice president of USA. And in the next example, I ask it to act like Kate, where Kate is an actor playing the role of the vice president of USA, which is slightly different, and this is just done to confuse the LLM. In all the examples, you'll see percentage time being used, and this is so that we get the CPU times and the response time, which you can see in the output, just to see how fast the model is. Now, all 4 of these Sam Altman emails are really good, and Sonnet has nailed the tonality quite right on each of the conditions that we gave it. Then we ask it the capital of England, but we ask it for a short answer, and right enough, you get London as the answer. Then we give it a timeline question to solve. Can Geoffrey Hinton have a conversation with George Washington? Here, Geoffrey is still alive, where George Washington died a long time back. But we don't tell this to the LLM, and it's supposed to figure it out on its own. And then we look at the output, and we see that yes, it does figure it out and gives us a detailed step-by-step answer for this. Then we ask it to write a story about a koala playing pool. Notice the system prompt here. We asked it to become a genius storyteller, and in the output you see a very nicely written story. A children's story, of course, because it's a koala, but it's still a good story. So far, Sonnet is totally crushing it with all the tasks. Now we will give it some code generation tasks. And while we will still use our generate functions that we had created earlier, but this time we will give it some code generation tasks. So the problem that I'm giving it is print all primes between 1 and n. And the system prompt here is that you're a genius Python coder. And now if you look at the output, you see that it generates the code for the solution of the problem. I feel it's not a simple solution. I mean, it might be efficient, but it's not simple. So I might not be using Claude 3 Sonnet for code generation. Then we ask it to detect if a number is prime or not. And in the output, it does look like it's able to find the right solution, and that's good enough. But I'm getting a feeling that Sonnet is too by the book when it comes to code generation. It's giving me efficient solutions, but not solutions that can be understood by someone who's just learning how to code. Now we give it some maths questions, just like we gave to Haiku a few videos back. I'm giving it a problem about apples, very basic maths, and we ask it step by step the reasoning for this question. And you see at the end, it gives you the right answer, which is 9. And to the same problem, Haiku was also able to give the right answer as well. By the way, these questions that I'm asking are not random questions. These are standard questions that are available on Hugging Face as well, and are used to test out models. So this gives us a clearer picture about the capabilities of this model. The next question is a fractions question about dollar per value calculation, and Sonnet again gets the right answer. The next question is quite lengthy. It's about a deep sea monster that eats people. Now, since this question is quite long, a human being might lose out on some detail and gets the wrong answer, or it might even take too long to calculate. But this is where LLMs shine, and you get the right answer along with proper reasoning. Finally, I give it an equations question, and it gets the right answer as well. Now, if you remember, recently in the LangChain, PalChain, and API chain video, we recently learned that LangChain has features to help LLMs solve math problems and also get accurate answers, because LLMs on their own are really bad at reasoning and maths. But seems like Sonnet is able to do a lot of maths heavy lifting without requiring LangChain, and this is really good. In an upcoming video, we will check out Opus, which is the biggest LLM by Anthropic, and we will test it out and see how much better it is than Sonnet. Now, a quick word about the sponsor of this video, which is you. Yes, you heard that right. You are the sponsor of this video, since this channel doesn't have any partnerships or sponsors right now. And this means that this channel is dependent on you sharing this video with your friends, liking and commenting on this video, because this is a small channel with very niche content and the algorithm doesn't really pick it up unless you share it. Thank you so much for watching this video. Don't forget to join our Discord where we talk about tech and hang out. The link for the server is in my YouTube profile. All right, I'll see you in the next video.